For the today lectures, we have the integral for the inverse trigonometric function. At the end of this lecture, you will be able to solve any integral for the inverse trigonometric function. You will find the solution in easy and simple way. Let's see how we will do that. As we can see here, this is the form for the integration and derivation for the inverse trigonometric function. And because we are only interested in the integral, we will focus only in the integral form. And I will show you how you will memorize these form of integrals. So these form of integrals, you need to memorize it. And how we will do that? Let's see. Notice how the integration form. We have integral 1 under root number to the power 2 minus variable to the power 2. If I see any integral in this form, so the result it will be directly inverse sign. And don't forget the angle u divided by a plus the constant number. Let's see the other one. We have integral 1 divided number to the power 2 plus variable to the power 2. If I see any integral in this form, the result of this integral it will be directly inverse tan. And don't forget 1 divided by a multiply inverse tan, and for the angle it will be u divided a plus the constant number. For the third integral, how it is look like? It will be integral 1 divided variable multiply under root variable to the power 2 minus number to the power 2. If we see any integral in this form, the result of this integral it will be directly inverse sec. And here 1 divided by a multiply inverse sec, and for the angle it will be u divided a. What we have else? The other important note that we will use the method of integration by substitution that we discussed before in order to put the function that we want to be integrated into one of the previous special form integrals. Let's see how we will do that in a practical way. Find the integral of the following function. We have this function, how we will solve it. Let's see. The first step that we have under root this part, we will try to arrange it like this. We have number, we will try to put it to the power 2. We will try to arrange this part to the power 2. How we will do that? It will be like this. We have 9, so it will be 3 to the power 2 minus we have e to the power 6x, it will be e to the power 3x all to the power 2. Next, what we will do, we will use the integration by substitution method to solve the integral. So what we will do, we will take the first step, it will be assumption. So it will be u equal, we will take this part for u equal e to the power 3x. Second step, the derivation. We will take the derivation for the assumption in both sides. So what is the derivative of u? It will be du. What is the derivative of this part? It will be 3e to the power 3x dx. As we learned from the previous lectures, we will divide both sides with the number 3. Why? To get this part of the integral, e to the power 3x dx. So the third step, substitution in integration with the variable u. We will substitute the integral with the variable u. We will get this result. Notice the integral form is the same as the integral form of the inverse function, inverse sign. As we learned before, we have number to the power 2 and we have minus variable to the power 2 all under root. So the result of this integral, it will be inverse sign, and it will be 1 divided 3 inverse sine for the angle u divided 3 plus the constant number c. Next, we will substitute the value of u. What is u? What we assume in the first assumption. It will be e to the power 3x. The final result, it will be this one. Let's see the second example. Find the integral of the following function. We have this integral. How we will find the solution? We will try to arrange the denominator to put it in the power 2. It will be equal integral x to, it will be under root 2 all to the power 2 plus x to the power 4. It will be x2 all to the power 2. Later on, we will use the substitution method that we will learn it in the previous lecture. So the first step, it will be assumption. It will be u equal, we will take this part for the assumption. So it will be u equal x to the power 2. Second step, we will take the derivation for the both sides from the assumption. What is the derivative u? It will be du. What is the derivative of x to the power 2? It will be 2x dx. We will divide it by 2 on both sides to get x dx. The third step, we will substituting the integration with the variable u. We have this integral. It will be equal 1 to the power 2 integral. This one, the number, will keep it as it is. x2, what is x2? From the assumption x2, it will be equal u. So it will be u to the power 2. X dx, it will be equal half du. And we can put the number outside the integral. The fourth step, notice the integral form is the same as the integral from the inverse function from this one. Because we have integral 1 divided by number to the power 2 plus variable to the power 2. We have number to the power 2 plus variable to the power 2. So the result of this integral, it will be inverse tan. So it will be 1 divided by a multiply inverse tan, and for the angle u divided by a plus the constant number c. After we find the integral in terms of u, we will substitute the value of u. What is u? From the first assumption, u, it will be equal x to the power 2. After finding the solution, inverse tan, now we will put it in the term of x. You only just substitute the value of u, and finally we will get the final result of this integral. Let's see another example. We have this example. Find the integral of the following function. We have this integral. How we will solve it? As we learn, we will try to arrange the denominator to put it in the power 2. So it will be equal integral 1 divided x, we will keep it as it is. For the root, we will keep it as it is. X to the power 4, it will be x2 all to the power 2 minus 25, it will be 5 to the power 2 dx. And we will use the same step that we will use it in the previous examples. We will use the substitution method to solve this example. Notice the first step, assumption. We will take this part for the assumption. So it will be u equal x to the power 2. Second step, the derivation. We will take the derivation for this assumption. What is the derivative of u? It will be du. What is the derivative of this part? It will be 2x dx. After dividing the both sides with number 2, we will have 1 divided by 2 du equal x dx. Notice that we are going to multiply the integral by x numerator and denominator to get the integral form of the inverse function. Of this inverse function. The result of this form of integral, it will be inverse sec. So we have this integral, we will multiply x in denominator and denominator. We will have this result. After multiplying x in numerator and denominator, the fourth step, we will substitute the value in terms of u. So x dx, it will be equal half du. The number, we can put it outside the integral. And x to the power 2, it will be equal u. It will be u. And under root x to the power 2, it will be u to all to the power 2 minus 5 to the power 2, we'll keep it as it. The result of this form of integral, it will be inverse sec. And don't forget, we just will be 1 divided by a. What is a? A, it will be 5. Multiply this part, 1 divided by 2. And u divided by a. It will be 5. Plus the constant number c. The last step, we will substitute the value of u. What is u? U, it will be x to the power 2, and we will get the final result of this integral. Let's see other example. Find the integral of the following function. We have this function. How we will find the integral? First, we will try to arrange this part to put this part in the power 2 and this part in the power 2. And how we will do that? It will be equal integral 2, we will keep it as it is, under root e to the power 4x, it will be e 2x all to the power 2, minus 7, it will be under root 7 all to the power 2 dx. And the step of the solution, we will use the substitution method to put the integral in the inverse form of integration trigonometric function. We will take this part for the assumption. Second step, we will take the derivation for this assumption. The derivation for u, it will be du. The derivation for this part, it will be 2 multiply e to the power 2x dx. Notice that we are going to multiply the integral by e numerator and denominator to get the integral form of the inverse function. The integral form for this inverse function, it will be sec. As you can see here, we have variable to the power 2 minus number to the power 2. So after multiplying the numerator and denominator by e to the power 2x, you will get this form of the integral. The next step, we will substitute the integration with the variable u. It will be integral 2e to the power 2x dx. This one it will be du. This part it will be du. Under root e to the power 2x, it will be u. E to the power tx, it will be u from that assumption. Under root this part, it will be u all to the power 2 minus the number, we'll keep it as it is, du. So the final result, it will be this form of integral. It will be inverse sec. And after we finding the result of integral in term of u, we will substitute the value of u to get the final result of this integral. This is for today's lectures, and see you next time.